Hi, and welcome to lesson 6 of the rates and equilibrium topic. Now, this lesson directly follows on from the lesson on reversible reactions because it's going to go through Le Chatelier's principle and how we can predict how an equilibrium will change based on how we change the conditions of the reaction. So I'm going to start by going through what Le Chatelier's principle actually tells us. And it's this bit I've just highlighted here. So Le Chatelier stated that the equilibrium position will respond to oppose a change in the reaction conditions. And what he meant by that was, if you change the conditions, then the equilibrium will move to get rid of that change. So if you increase the concentration, it will make it so that a reaction happens that will reduce that concentration again. Or if you increase the temperature, it will make it so that the endothermic reaction happens more so that the temperature comes down again. The equilibrium will move either left or right in order to get rid of the change in the reaction conditions and bring them back to what they were before. And what you guys need to be able to do is you actually need to look at these three factors here, and then you need to be able to predict the shift. So you need to look at a reaction and say, this has changed, it's going to move either right or left and favour whichever reaction it favours. So you need to understand how and why that works. So let's start by looking at changing the concentration. So if you change the concentration, you change the relative quantities of your reactants and products. Remember, from earlier in this topic, we said that concentration increases increase the rate, and that's because you have more collisions. So the same thing will happen here. It will have a similar effect. If you increase the concentration of a particular substance in that reaction vessel, there are more of it moving around, which means they are more likely to collide with something else, and we get a frequency of successful collisions increasing. So if we look at it here, if we've increased the concentration of A, so you can see that I've made A a bit bigger than I have B, C, and D, what will happen is the equilibrium will move. I'm just going to write it here. So the equilibrium will move to reduce the concentration of A. So you've added in extra A. Your equilibrium is now going to shift to get rid of that extra A by making it react. I'm going to just add that there. So what actually happens is this. You've got more A in here, so more collisions are going to happen. Because there are more collisions happening, you now are going to see our equilibrium shift right. It's going to move that way. And I've actually tried to show you that by drawing this half arrow a bit bigger. So that's showing you that actually there are more forwards reactions happening than there are backwards reactions happening. And what will eventually happen is it will continue to do that until A starts to reduce, and then it will shift back to equilibrium where we will have, say, for example, one forwards and one backwards happening at the same time. So what we get is we get more reactions moving forwards. Now, in an exam, you might be asked to predict this, and what you should actually say is that it shifts, equilibrium shifts to the right to oppose the change and reduce the concentration of the reactants. And you can also use the term that it favours the forwards reaction, because it does. It's moved right in order to reduce the amount of A, and so it has favoured that forwards reaction. There are more forwards reactions happening than there are reverse or backwards reactions. And the same can be said if we were to change the concentration of C or D. If you've increased the concentration there, then you're going to need more reverse reactions to reduce their concentration. They might also ask you what would happen if you took away some of your products. So say, for example, you decreased, and I'll do that here now. So if you decreased the concentration of C, what would happen is you need to make more C. To reduce the change. Now, the only way to make more C is to increase the rate of the forwards reaction. And so what we would say here is that the equilibrium will once again shift right. So they could do this in one of two ways. They can either increase the concentration of each side of the reaction, or they could decrease the concentration of each side of the reaction, and you need to be able to predict what's going to happen in each of those cases. Okay, guys, so let's move on to looking at how changing pressure can affect a reversible reaction. Now, the key thing to remember here is, just like we talked about in a previous video on the factors that affect rate, this will only work if you have a gas phase reaction. So you need both sides of your reaction mixture to be gases, otherwise pressure won't affect it. And so what happens when you do this is, if you change the pressure, you alter the space between the molecules. And if you guys can remember from a previous video, if you increase it, you reduce the space, you bring them together. Whereas if you decrease the pressure, you increase the space and you actually move them further apart. So when you look at Le Chatelier's principle in terms of pressure, what you actually have to do is you have to count the number of molecules on each side of the equation. So if we look at this example here, I'll just stick my green back on that pen for you guys. What we have on this side is we have 2, and unfortunately we don't have a coefficient here on this side. So what that tells us is, for every 2 molecules of this, we get 1 molecule of that. So if I was to increase the pressure of this reaction mixture, it would shift to, and this is a key point that you guys need to remember, it would shift to reduce the number of molecules, because if you have less molecules, then you decrease the pressure. And so what would happen here is, if we were to look at this part of our reaction again, we would see that actually we would get a shift and we would get more forwards reactions happening if we increase the pressure. That would shift our equilibrium to the right and favour the forwards reaction. Because what we're going to do is we're going to reduce the number of molecules in the reaction vessel, which will reduce the pressure. If we were to do the opposite of that, and if we were to decrease the pressure, what you would see happening is more of the reverse reactions. Because we've got a decrease in pressure, we need more molecules in that space to increase the pressure again to where it was. The only way to do that is to have a reverse reaction happen and create these 2 molecules of nitrogen dioxide. So when we're talking about pressure, what we're actually talking about is how many molecules there are in our reaction vessel. If we increase the pressure, we're going to want to reduce the number of molecules, so we will shift to whichever side has the lower number of molecules on it. And so it will either shift right or left and favour either the forwards or the reverse reaction. Okay, guys, so the last one is looking at our temperature change. And I've already mentioned this once before, but when we're talking about temperature changes in terms of Le Chatelier's principle, we are relying on the fact that our reactions are going to be exothermic or endothermic. So let's start by looking at if we have a exothermic forwards reaction. So if our forwards reaction is exothermic, then remember what I said before, exothermic reactions don't like temperature increases. They are going to release energy. They don't need energy put into them to get them going and keep them going, unlike endothermic reactions. So if we have an increase in temperature change, we will actually have a favouring of the reverse reaction, because the reverse reaction is endothermic. What that means is we will get more reverse reactions, and that's because our equilibrium has shifted left. And the reason it's shifted left is because it wants to reduce the temperature. And the only way to reduce the temperature is to absorb it. And endothermic reactions do that. Now, if we look at if the forwards reaction was endothermic and we increased the temperature, it would favour it. Endothermic reactions want energy, or need energy, I should say. So if we have an endothermic reaction and we increase the temperature, what we are going to see is we're going to see more forwards reactions. And the reason for this is we want to lower the temperature. And the only way to lower the temperature is to absorb it. And if we are absorbing the temperature, we want more endothermic. Sorry, that was a bit messy. More endothermic reactions. And the only way to have more endothermic reactions is to shift the equilibrium right and favour that forward endothermic reaction. So in an exam, they might ask you something like, here is an example of a reaction, and they'll give you an energy change. And if it's negative, remember, it's exothermic. And if it's positive, remember, it's endothermic. And then they will expect you to look at that energy value for the reaction and see that the forwards reaction is exothermic and they've increased the temperature. So you would say this would shift the equilibrium left and favour the reverse reaction to decrease the temperature, or vice versa, whichever way around it is that they're doing it. So this last slide in the video, I'm going to leave up for a little while and just talk to you, because this is a help sheet that I wrote for a class a couple of years ago and works really well helping people while they're answering exam questions. So please feel free to take a screenshot of this if you want to. It will help you work out what's going on in an exam question. What it is just a set of steps that you can do when you are looking at an exam question that will point you in the right direction. So start by looking at what your exam question is telling you. Is it telling you that you're increasing concentration, changing the temperature, or changing the pressure? Once you've decided which one of those factors it is, then look at the steps that are underneath it. So if we have a change in temperature, the first thing I want you to think about is it exothermic or is it endothermic going forwards? If it's exothermic and you've increased the temperature, you need to decrease your products and shift to the left to decrease the temperature again. You need to go in the endothermic direction, which is the reverse. If it's exothermic and you've decreased the temperature, you need to increase your product to increase the temperature back up again. So that shifts to the right and favours the forwards reaction. So as you can see, if you can work out what they are asking you, you can then ask yourself these simple questions and they should lead you to the correct answer. Eventually, you won't need to use these anymore. because you'll be so used to asking yourself those questions, you will get there without this there helping you. So remember, we've got three things that affect the position of the equilibrium. Concentration. The concentration will shift the equilibrium to reduce the increase or increase the reduction in a particular concentration. So if you increase the concentration of the reactants, it will shift right to favour the forwards reaction and make more product, which will decrease the concentration that you increased in the beginning. If you have pressure, pressure only affects gases. And so what you need to do there is look at which side of the reaction has the most molecules. If they increase the pressure, it will go the opposite direction to reduce the number of molecules. If they decrease the pressure, it will go in the other direction to increase the number of molecules. And then finally, temperature. Temperature will be determined based on whether the forwards reaction is exothermic or endothermic. If it's exothermic and you increase the temperature, it will favour the reverse reaction, which will shift it left so that it can reduce that temperature by absorbing it. And if it's an endothermic reaction and it increases, it will shift right to favour the forwards reaction so it can also absorb the energy and reduce the temperature. Okay, guys, thank you for listening. For those of you who are doing triple chemistry, I will be back with another video which will look at how we use equilibrium reactions in industry to make things like ammonia and our fertilizers that we use to grow crops and things like that. Okay, thank you for listening, and I will see you guys soon.